Alright guys, we're going to talk about rational equations. A rational equation is similar to a rational number. A rational number is just a fraction. Anything that can be written as a over b. So a rational equation has fractions in it. It also wants us to check for extraneous solutions. So make sure you know the definition of an extraneous solution. That's a solution that you get when you solve the equation, but when you plug it in, it doesn't work. So what does that mean? That means you have to check your answers each time to see if it works or not. Alright, and a lot of times we're going to be looking at the denominator for that because you can't divide by 0. Alright, let's get started. First thing I want to do here is get a common denominator. If I have a common denominator, then I can get rid of my fraction right away, and that will make it a little easier. Since this one has 5x and this one has 5x, I need the first one to be 5x to have a common denominator all the way across. So I can rewrite 1, if I can find the correct pen here, as 5x divided by 5x, because anything divided by itself is the same thing as 1. And then I'm going to add that to 1 over 5x. I'm not changing that yet because that's going to work for us right now. Now, when I look at this, I have a 5x, a 5x, a 5x. So the first thing I do, get a common denominator, and then I can multiply the whole equation by the denominator, and it will cancel because that's essentially on top, anything over 1. This is on the bottom, so it's going to cancel out the left side and the right side if you multiply both sides by the common denominator. So what does that leave? 5x plus 1 is equal to x plus 7. And then we're going to solve, subtract x. So 4x. I'm also going to subtract 1. So that's going to give me 7 minus 1 is 6, divide by 4, and x is equal to, this can be reduced by 2, so 2 goes into 6 3 times, 2 goes into 4 2 times. So 2/3 is the answer I get. And then you're going to plug it in to see if that works. Okay, so if you plug in I'm going to have 1 plus 1 over 5 times 3 halves. And I'm checking this, so I want to know, does that equal 3 halves plus 7 over 5 times 3 halves? So this gives you some practice with fractions again as well. So remember, you can put any number over 1. I'm going to leave this for now, and I've got plus 1 over, and this becomes 15 over 2. And I'm still checking this to see, and I need a common denominator here to add fractions. So I need to multiply this one by 2. So I've got 3 plus 14. So I've got 17 over 2 on the top. And then on the bottom, I can change that to a fraction, and I've got 15 over 2 again. Alright, now, this is the same as a fraction. I can just multiply by the reciprocal. So I'm going to do 1 plus 2 over 15. So I need to make this a common denominator, so I'm going to multiply by 15, so it's going to be 17 over 15. Okay, still checking. Here I'm going to multiply by the reciprocal here. So I'm going to have 17 halves times 2 over 15. The 2's cancel, and that becomes 17 over 15. So this checks out, so that means this is a good solution. It is not extraneous. Okay? Remember, an extraneous solution is a solution that you get that when you plug it in, it doesn't work. Okay, so there's a lot of work to these to first find the answer and then check them as well. Okay, let's see if we can look at another problem here. Alright, so what would our common denominator be? Our common denominator is going to be 6v. Okay, when it has a 1 there, that's easy because we can put anything over itself and it still equals 1. So this one's kind of easy like the last one. So we're going to have v minus 6 over 6v. That one doesn't change. It already has the denominator that we need. And now we're going to write 6v over 6v, which is the same as 1, and then minus 1 over 6v. Now that I have all of my denominator the same again, I'm going to do the same thing as I did last time, multiply by 6v over 1. Since this is on top and this is on bottom, it cancels with our denominator. So I'm going to have v minus 6 equals 6v minus 1. And that's just from the numerator. Everything on the numerator you keep exactly like it is, and then you solve. So minus v, so 5v, and then I need to add 1. So that's going to be negative 6 plus 1 is negative 5. Divide by 5, v equals negative 1. Okay. Now I can check the denominator first. Doesn't make the denominator equal 0, so that's a good thing. So then we got to plug it in and check it. So here we're going to have negative 1 minus 6 over 6 times negative 1. Alright, and then 6 times negative 1. Alright, now what we're doing is we're checking this, so I like to put a little question mark here that says, does this work? Okay, so negative 1 minus 6 is negative 7. Negative 6 times negative 1 is negative 6. And then we have negative 6 as the denominator here, so we need this to be negative 6 over negative 6. Because when you add or subtract, you have to have a common denominator. Now, two negatives make a positive, so we can just write this as 7 over 6. And then we get negative 6 minus 1 is negative 7 over negative 6 again, which again, two negatives make that positive. So that works. And again, this is a good solution. All right. All right, next problem. Okay. All right, common denominator. The first thing I'm going to do here is, first I'm going to try to write just a little bit smaller because this may take a few steps. So I'm going to have 1 equals 1 over x plus x squared minus 9x plus 14. And the first thing I'm going to do is factor the denominator here and pull out the x. And the reason for that is I'm trying to get a common denominator, but I don't want it to be any bigger than it has to be. So since this already has an x, and I can see that this has an x as well, now I can multiply this by x minus 1 instead of x squared minus x. So this 1, again, can be anything. So I'm going to make it x times x minus 1 over x times x minus 1. Anything divided by itself equals 1. So I still have 1 there. And then I have 1, and I need an x minus 1 on the second term. And then I have an x here on the bottom, and I need, whatever I do to the top, I have to do the same thing to the bottom. Because this has an x minus 1, this one also, and this one needs an x minus 1. Okay? Adding fractions have to have a common denominator. I'm still going to leave the numerator alone for right now. And then x times x minus 1. All right, from the first two problems, you could see that I multiplied by the denominator, and that got rid of my fraction. Okay, that still applies here. So I'm going to get rid of all this fraction. Multiply this side by the same thing. All right, so I'm going to go ahead and distribute as we go just because we're running out of space. So x times x is x squared. X times negative 1 is negative x. Equals 1 times x is x, and 1 times negative 1 is negative 1. Excuse me. All right, now I just copied the rest of it down exactly like it was. Because this already had the denominator, we didn't have to change the numerator at all. Now I'm going to combine like terms or just kind of solve. First thing I can do is subtract x squared. It cancels from both sides. And then I'm going to subtract x. So I get negative 2x here is equal to negative 9x plus 14. Well, I still have an x on both sides. So now I'm going to come up here and try to finish it. Negative 2x is equal to negative 9x plus 14. So I'm going to add. So negative 2 plus 9 is 7x is equal to 14. And that gives me 2. I feel like I did something wrong here. Let me look back over here. Oh, I forgot a negative 1 down here. I was going to say that did not look right. Bear with me if you're still trying to catch up. Go back here and erase this up to here. Back here, I'm going to highlight this. It's what happens when your work is all sloppy. Sometimes you miss things. All right, so I brought down, or I subtracted the negative x here, and I subtracted the x squared, but then I subtracted and got negative 2x, and I just lost that negative 1. So I'm just going to tack that negative 1 on up here and make sure I don't lose it. So I get negative 2x equals negative 9x, and now I have plus 13. Add 9x. That becomes 7x is equal to 13. And what do you know? The last answer looked nicer. But I know this answer is correct because I have the answers in front of me. All right, so again, I apologize for my poor writing skills. I write better on paper or the board, but writing on the computer is still kind of new to me. All right, so you'd have to go back, plug this in, make sure it's not an extraneous solution. If you plug it into the denominator and it doesn't equal 0, most of the time you're pretty good. So I hope this at least gets you started, and I hope you don't have too many questions about this.